Today I am discussing about the Fourier series. It is the one of the most important mathematical tools in signal processing and engineering. In this, I am discussing about trigonometric Fourier series and exponential Fourier series, cosine Fourier series, and discrete conditions. This is presented by G.V.S. Amarendra Reddy, with registered roll number 24BQ180436. Introduction to Fourier series. Fourier series is a mathematical method that allows to represent the periodic function as the sum of simple sine and cosine functions. It was developed by the Joseph Fourier and widely used as electronic in engineering and communication, vibration analysis, and many other fields. In simple words, Fourier series break down as a complex periodic signal into basic loop. Now see here. Fourier series helps us to express a periodic function as the sum of the sine and cosine functions. This is developed by the Joseph Brete. This is developed by the Joseph Fourier. This is used in signal processing, vibration analysis, instant transform, etc. Periodic functions. A periodic function is the one of that repeats itself af- after a fixed interval called the period. For example, sin x and cos x repeat after 2 pi. Fourier series works only a such periodic function. This is why understanding periodicity is essential before applying the method. Trigonometric series general form. The trigonometric Fourier series expresses a period function as a sum of the sine and cosine terms. F of t is equal to a naught plus summation a n cosine omega t plus b n sin omega n omega naught t. Here, a n and b n are the coefficients of trigonometric Fourier series. Here, omega naught is equal to 2 pi f by t that is a fundamental frequency. This is represent extremely useful because sine and cosine are simple to work as with a mathematically. Calculating coefficients. The coefficients are found using the integration over a one period of the function. A naught represents the average value, that means DC component. An and Bn represents the amplitude of cosine and sine components of the different frequencies. By calculating this we can reconstruct the original signal accurately. Here, A naught is equal to 1 by t integral f of t dt. An is equal to 2 by t integral f of t, sorry, t to t plus t here, integral t naught to t naught plus t, cos n omega naught t naught. Here, Bn is equal to 2 by t integral t naught to t naught plus t f of t sin n omega naught t dt. Now we are moving to the exponential Fourier series. We can also express the Fourier series using exponential functions. This formula is the formula of exponential Fourier series. F of x is equal to summation n is equal to minus infinity to infinity cn e power jnx. This is a component of an elegant. It uses formula e power jx is equal to cos x plus j sin x. This is especially useful in electrical engineering and communication system where complex exponentials are common. Here, where Cn is equal to 1 by t integral f of t e power minus jn omega naught t dt provides a compact reference using complex exponential. Advantages of exponential form. Exponential form simplifies mathematically multiplication, especially in different equations. And exponential form symmetric between positive and negative frequencies and useful engineering applications like Fourier transformers. Now we are going to Cosine Fourier series, or even it is also known as even function. If a function is even, we only need the cosine terms, since sine terms are cancelled out. This reduces the competition and simplifies the Fourier series. This is why the cosine series are commonly used in applications like image processing and heat transfer problems. For a even periodic function, f of t is equal to a naught plus summation a n cos n omega naught t. Now we are moving to the Dirichlet conditions. Dirichlet conditions tells us when a Fourier series converts to a function, that function must be f of t must be periodic, f of t must be absolutely integrable over a period, f of t must be have a finite number, discontinuous, f of t must have a finite number of maximum and minimum. If these conditions are satisfied, the Fourier series will correctly represent as a function. Physical interpretation of Dirichlet conditions. Physically, Dirichlet conditions ensure that the function is well behaved. For example, a signal with a finite discontinuous cannot be reconstructed with a finite cosine terms. Applications of Fourier series. Fourier series has wide range of application. First one is signal and image processing. Second one is electrical circuit and filter design. Third one is heat conduction process. And fourth one is vibration analysis in medical system. Fifth one is audio compression and music synthesis. Essentially, when a period signals are involved, Fourier series can be applied. At last, the conclusion is to conclude the Fourier series is a powerful mathematical tool that allows us decompose periodic signal into a simple harmonic compounds in a bridge between time domain and frequency domain analysis forming the basis for Fourier transform and many other techniques in a modern engineering. Fourier series is a powerful for analyzing periodic signals. Different forms of Fourier series is trigonometric Fourier series, exponential Fourier series, and cosine Fourier series should be suitable in different problems. Dirichlet conditions ensure the convergence. The reference of the Fourier series is Fourier series theory textbooks and online engineering sources.